This is PreAP PreCalculus section 3.6 notes. This is the last notes of the chapter. And these last problems we are looking at an equation, and we are going to graph this without a calculator. And it's not going to be 100% accurate, but it's going to be pretty stinking close. And we're going to do this based upon the zeros of the function and their multiplicities, as well as the end behavior of the graph. And I think this is pretty cool. If the given function is not already factored, completely factor each of the functions below. So this is going to need factored. Completely factor. Then identify the zeros and the multiplicities. So there's two things to do there, three things total. Then using the zeros and the end behavior, sketch a graph of the function. So you have to also figure out what the end behavior is. So let's see if we can factor this little fella. Actually, before we factor it, let's just talk about the end behavior. This is an odd degree, so that means the end behaviors are opposites. One's falling and one's rising. Leading coefficient's negative, so that means that it rises to the left and falls to the right. So we know the end behavior is like this, so we know this graph is going to be up here someplace and down here someplace. Factor this, let's factor out the greatest common factor, which appears to be a -2. Let me rephrase that, a -2x, leaving us with x squared plus 4x plus 4. Now that's a perfect square trinomial, this little fella right here. Factors into a -2x, and then we're going to have an x plus 2 quantity squared. So here's what this tells us. We have a 0 at 0. And we know that it's odd multiplicity, which means we are crossing. Actually, we know a little bit more than that. It's an odd multiplicity of 1. So we know it crosses here. At x equals -2, this is an even multiplicity of 2, so we know that it's tangent. If we combine the fact that we know this is odd, it crosses, this is tangent, it's even, and we know the end behavior rises to the left and falls to the right, the only way this can be drawn is to come down here, touch this, it's got to come back down to cross at 0, and it can never come back up because it never crosses the x-axis again. So your graph's going to look something like that. Now, when it comes up, how far up does it go? We don't know. Maybe it's a lot. Maybe it's a little. That's why I'm saying that our graph's going to be kind of accurate. So it comes down, comes back up, comes back down, doesn't change concavity at that 0. So your graph looks something like this. Let's look at g of x, also not factored. We can factor this by grouping. So if we factor this by grouping, a GCF of the first group is x squared, leaving us with 2x plus 3. GCF of the second group is a -9, leaving us with 2x plus 3. Could factor the 2x plus 3 out to the front. X squared minus 9 is behind it. X squared minus 9 is the difference of two squares, which factors into two binomials, an x plus 3 and an x minus 3. Now, this right here, this is important to me that I actually factor out this 2. I would like to be able to look directly at this and know what my zeros are. And I can do that here and here. Here it's not so easy. So even though 2 is not a factor of 2 and 3, I can still factor it out. That's going to give me x plus 3 halves. By doing that, that tells me in its fully factored form, negative 3/2 is going to be a 0 of this function. I would like all of my coefficients for x in my factors to be 1. So let's put these zeros on here. Negative 3/2 would be like negative 1.5. When I say like, I mean exactly. Excuse me. This is odd of 1, so it's crosses. X plus 3 is a factor, therefore negative 3. This is also odd, degree of 1, so it crosses, doesn't change concavity. And then x is positive 3 is another 0. This one is odd, degree of 1, so it also crosses. So these are all crossings. As far as end behavior goes, this is a cubic function, so the end behaviors are opposite. Leading coefficient's positive, so that means that it falls to the left and rises to the right. So I need a graph that falls to the left here, rises to the right here, and then in between is intersecting these x-intercepts. So your graph could look something like this. Comes up, it's got to come back down. At some point, it's got to come back up. And when it does, it never comes back down. I'm going to include something in this that I didn't talk about in the previous one. What's the y-intercept of this graph? Well, it's a negative 27. So I can come here and I can say, oh, this may or may not be a minimum there, but I can say this is crossing at negative 27. On the previous problem, there was no coefficient, so the y-intercept was 0. That's why I didn't actually mention it on the previous one. All right, let's see if we can do some more of these fellas. Hey, this one's already factored. That's going to make this easier. The zeros for this are negative 2. It's an odd multiplicity. Positive 1, odd multiplicity. Positive 3, odd multiplicity. What about the end behavior? For the end behavior, we need to multiply this whole thing out, which I don't want to do. We only care about the leading term. So if I multiply x by x by x, that's going to give me 1x cubed. And then we're going to have some terms in the middle. I also want to know the constant. The constant can be found by multiplying 2 times negative 1 times negative 3. That's a positive 6. This tells me that this crosses the y-axis at 6. This x cubed tells me that the end behaviors falls to the left and rises on the right. Once again, these are all odd multiplicities, so the graph could look something like this. Make sure we're not changing concavity at any of the x-intercepts. We have no idea how high this goes. We have no idea how low this goes. We do know it crosses here at 6. Done. H, we have factors of, we have zeros of negative 2 and positive 2, even multiplicities. So the graph is tangent there. If we were to multiply x squared, so if you multiply x plus 2 times x plus 2, we have an x times an x. You multiply an x minus 2 times an x minus 2, you have an x times an x. So that means our leading term is going to be x to the 4th. We're multiplying it by this negative, so it's negative x to the 4th. We don't necessarily care about the middle terms. We do care about what this last term is. A negative 2 times a negative 2 is going to be 4. 2 times 2 is going to be 4, because we got this squared. That's going to be 16, 4 times 4. And this says change the sign. So we're going to have a negative 16 at the end. That means our y-intercept is down here someplace at negative 16. As far as end behavior goes, It's an even degree function. Therefore, the end behaviors are both up or both down, both the same. This negative tells us that the end behaviors are both down. So the graph has to go up, hits this x-intercept, comes back down because it's tangent. Maybe the minimum's here at negative 16. Maybe it isn't. We know it touches the y-axis at negative 16. It's tangent at this 0 and comes back down. End behaviors are right. It's falling left on the left and the right. The zeros of negative 2 and 2 are tangent. The y-intercept's negative 16. We are checking all the boxes. Now this next one, I don't like how this is written, quite frankly. This bothers me to no end. I'm going to rewrite this as a negative x plus 3, and I still don't like it. I want this coefficient to be positive. So I'm going to factor a negative 1 out to the front. I'm going to change this to an x plus 1 squared, because the multiplicity is 2. And when I factor a negative 1 out of negative x plus 3, it makes it a positive x minus 3 when I pull that negative 1 out front. So I have a 0 at negative 2. I'm sorry, at negative 1. It's an even multiplicity. It's tangent. And at 3, it's crossing because it's an odd multiplicity. If I were to multiply this stuff out, I would have x times itself, because it's going to end up being squared, times another x, that's x cubed. Change the sign here, negative. 1 squared is 1, times a negative 3 is negative 3, times a negative is a positive 3. So this crosses the y-axis at 3. As far as end behavior goes, this is an odd degree. The leading coefficient's negative, so it falls to the left and rises to the right. Let me rephrase that. That's wrong. It rises to the left and falls to the right. Anytime I make a mistake like that, I want to go back and check to make sure. Okay, I didn't make that mistake anyplace else. So, if it's rising on the left, that means it's coming down and hitting this x-intercept, and it's tangent, so it comes back up, goes through 3, and then comes back down, crosses there, and goes down forever. So it could look something like that. G of x, if I were to multiply this out, we're going to end up with x cubed. X squared times x is x cubed. 1 squared is 1 times a negative 2 is negative 2. And these middle terms are whatever, and the y-intercept is negative 2. We have a tangent x-intercept at negative 1. We have a crossing x-intercept at 2 without changing concavity. End behavior for this falls to the left, rises on the right because it's an odd degree, leading coefficient's positive. So the graph could look something like this. Now K, we got to be careful about. This is an odd degree. It's 3. So at 1, it is odd, so it crosses and also changes concavity. Tell you what, instead of writing concavity change, let's just write point of inflection, which means that. Less writing. Negative 3 is the other one, and it is crossing there. Does not change concavity. If we multiply this out, a negative 1 cubed is negative 1 times a positive 3 is going to be a negative 3. X to the first times x cubed is going to be x to the fourth. That tells us that the end behaviors are the same because it's an even degree. Since this is positive, this is opening up. Looks something like this. So we know that it is crossing. at -3. We know the end behavior is going down. We know the end behavior going left is going up. So as we go left, right, we're going down. Don't know what's happening in the middle here. But I do know that when it comes up to this, changing the concavity. Hopefully you can see how this is concave down, this is concave up. I'm going to also mark the y-intercept of -3. It's subtle. Hopefully you can see how the concavity is changing here. That's because this is an odd degree. That's at least 3. Last one, I hate this. I'm going to rewrite this as -2x plus 3. And guess what? I hate that as well. I'm going to pull a -2 out to the front. I'm just going to move this over here as well. If I pull a -2 out, that's going to make this x minus 3/2. And hopefully you can see that that means that the x, that the 0 for that's going to be a positive 3/2, which is 1.5. Then we got the x plus 3, and then we got the difference of x and 3 squared. If we multiply all this jazz out, we got x times x times x squared, that's x to the 4th, times the leading coefficient. We have multiplying -3 squared is 9, times positive 3 is 27. And then if you multiply -2 times this, we're going to get a positive 3. 3 times 27 is 81. If you have a hard time with what I'm saying for all that, you can just multiply this whole thing out. But we only care about the first and last terms. All right, so we have an x-intercept at positive 1.5, 3/2, and it crosses there. Doesn't change concavity. We have one at -3, crosses, doesn't change concavity. We have one at positive 3, and it's tangent. End behavior is going down on the left and the right. Who knows what's happening in the middle, but it's going down on the left and the right. So we come up, we got to cross the x-axis, and then we come back down, we got to cross the x-axis. We come up, it's tangent, and comes back down, which must mean this here is 81 because we said it crosses the y-axis at 81. All right, well, that concludes this chapter. Hopefully things are coming together for you as we get to the end and we're putting everything together. Please do the homework for 3.6.